Okay, this is from lesson 1.4. We're going to look at dot plots. So here's the second video for lesson 1.4. So dot plots are another type of graph. And so what we're looking at here is you see some of the answers already put in, but we'll talk through this here. A dot plot is very similar to a histogram, as what we saw here. The difference is the dots. I can actually count the dots instead of making a bar. And then we can actually look at, like in this case, a dot can mean one person or can be more than one person. But look at this here. The graph below represents the first exam scores for 100 students. So each dot represents one student. Study the dot plot was the most common score in the exam. I can see the highest one is the most common, and that is the score is 75. And it looks like how many students earn that. You can count the dots. 1, 2, 3, 4, 5, 6, 7, 8. Right. So in this case, 8 students scored a 75. What percent of all students scored 90 or above? And so here's 90 or above. I circled that. And there are 10 out of 100. And so 10 out of 100 is 0.10 or 10%. And so 10% of students scored. And so you can see, but from the dot plot, you can kind of answer some questions regarding the number of students that scored a certain percentage. And so looking at that, here's another example of a dot plot. This was a little bit more complicated because in this case here, each dot, in this case 5 dots here means 5 million households. And so in this case, one dot is worth, means 1 million people. And so right there, I want to make sure we got that. So notice again, dot plots are handy, but we can, each dot can represent a different value. So make sure you're reading that real quick. We'll pause. Okay, now that you've done reading that, let's see if we can answer some questions here. And again, here's the first situation, number 10. There's a study that says that when you make $75,000 or more, there's no gain in happiness in your life. And so how many households made between 70 and 74,999? So you have to read this. I've highlighted the set of dots already that represent that number, but you can see if this is 50 to 54, then this would be 55,000, 60,000, 65,000, 70,000 to 74,999. And so then we're looking at that value right there, right? And so with that in mind, then how many households is that? That is 4 dots, right? So this is 4 dots. But that 4 dots equals, 1 dot is 1 million people, so this is 4 million. 4 million. Sorry for my writing. This pen just doesn't write that well. 4 million people right there. Okay, so that's the answer to number 10. And then again, you pick your own dot and try to make an interpretation. So if you pick this 1 dot here, this looks like 190,000. So there's 1 million people that make 190,000 or more in terms of the income here per this graph here. So that's a dot plot. Now the next questions where you're going to be asked about are distribution. So you're going to read that. There's no answers here. Well, not yet. I don't want to show you the answers, but that's where you're going to be turning in. You have a distribution. Let me just explain what that is real quick. And so when we make graphs, we describe them certain ways. So one way is either called bell-shaped, normal, or symmetric, and it has this shape here. Another type of shape you can get for a graph is called left-skewed, right? There's a long tail on the left. Let me highlight right there. Tail's going out to the left, this tail. And then you have something called right-skewed. So you're going to be kind of looking at that here as you go through that. And here again, this is a bell shape or symmetric. So on some of the questions for your discussion, you're going to have to look at that. So go ahead and I'm going to skip ahead to after that, but that's part of the discussion. So kind of finish our discussion. Again, you're turning in problems 12 to 15. But to kind of help you again, here are the rest of the answers to this section here. Based on the graphs above, we have again these pictures here that I've drawn. Again, you're going to use these ideas to help you. On top, you have I showed you in that web page, the skewness, something that's bell-shaped or normal distribution or symmetric would look like that. And again, you can use those answers to kind of compare and help you solve problems 12 to 15. And then to finish this lesson here, we get into something called relative frequencies. And again, I just want to show you some of that work here. Again, it's a histogram, so instead of putting a frequency here, we can do what's called relative frequencies, and that's just the percentages or the decimal points. And so you can see this was the original histogram we had, and so instead of using 7, notice we use 0.16, and you ask yourself, where did I get that from? It's because, again, remember there were 44 total data points, and instead of 7, I do 7 divided by 44. And so another way to draw the histogram is through with relative frequencies. And why people like that is because it gives us an idea of percentage. And so notice you have these values here that get turned into decimals, and then we report them as percentages. So now we can make statements such as, 16% of the people took between 0 and 14 minutes to commute, or 39% were between 15 and 29 minutes. So we can speak that language. So you're going to be working with relative frequencies. Again, you can go in the prep and homework to get your extra practice here. But again, notice how I did the calculations over here to do relative frequencies. And so answering some questions here, some of the answers to the questions here, and you can see where I'm getting those values from. And so how many people have 15 to 29? That's frequency, right? How many total data points? And then that gets turned into a relative frequency. So there's multiple ways to report an answer. So I want to make sure you're going back into kind of understanding that the graphs are the same. The only difference is that we're reporting them as decimals and percents. So this becomes 25%, 5%, 7%. Right, and so that's another way to analyze a graph.